Hi all, this is E. Manjula, lecturer in Electrical and Electronic Engineering from Government Institute of Electronics, Secunderabad. So today I am going to deal a subject network analysis and electrical machines, which is in EIE syllabus. And today we are going to see about Ohm's law and Kirchhoff laws. Okay, the objectives that we are going to cover is definition of the current, definition of the voltage, Ohm's law and its limitations, definitions of various terms which are used in electrical circuits, and Kirchhoff current law, Kirchhoff voltage law. So current, here current is, what is a current actually? A current is a flow of electrons. The rate of flow of electric charge in a circuit is called current, and it is measured in amperes. Here 1 ampere is equals to 1 coulombs per second. That is, which is equals to 6.25 into 10 to the power of 18 electrons per second. And current direction is taken as direction of positive charge flows. So the current direction will taken as positive charge flow. It means like, if example, this is a circuit, a battery, a resistor, sorry. Okay, so the direction of the current is taken like this, from positive to negative, but actually the electrons will flow from negative to positive. For the conventional, in any circuit it is taken, the current direction is from positive to negative. Voltage, the voltage is electrical potential energy per unit charge, and it is measured in volts, and 1 volt is equals to 1 joule per coulomb. So ground is the 0 volts reference point. So always ground has 0 volts. And it is indicated by V symbol. So this is about the voltage. Now we will see the resistance, an element which is used in almost all circuits. Resistance, this is a symbol of the resistance. And restriction to charge flow. So what a resistance will do? It will oppose the flow of electrons. So if the resistance value is high, the current value will be less. So it is restricting the flow of charge. And it is given by letter R, and the units is ohm. So we will see that here the definition of Ohm's law, that is a statement of the Ohm's law. Okay, here it is saying that the ratio of the potential difference between any 2 points of a conductor to the current flowing between them is constant. That it is V by I is equals to constant, provided the temperature of the conductor does not change. So the temperature of the conductor does not change. So there is a statement states that the voltage applied across a circuit, here the current flows in a circuit is directly proportional to the voltage applied across the circuit, provided the temperature is constant. This is the statement, okay? And the definition is this. So here this is a current, and this is the voltage, and this is a resistor. Okay. One second, I'll take the arrow. Okay, so this is voltage, current, and resistor. So, according to the definition, that is V by I is equals to constant. Okay, can anybody guess that the Ohm's law has got some limitations? Okay, let us see these limitations. The limitations of Ohm's law. Ohm's law is not applicable to. Ohm's law is not applicable to for metals which are heated by the current to large extent. Means there are some metals which are heated up by the current which are flowing, the current which is flowing through the metal. Okay, it means that there is a change in temperature, the current is changing the temperature. So for that metals the Ohm's law does not applicable. Second one, for electrolytics where enormous gases are produced on either electrodes. So for electrolytes also it is not applicable. And for vacuum tubes and arc lamps, and for gas filled tubes in which the ions are generated as the current passes. So these are some of the limitations where Ohm's law does not applicable. I can say that even this Ohm's law does not applicable for semiconducting devices and any of the metal which is affected by the temperature. Where there is a change in temperature, at that part the Ohm's law is not applicable. Fine. uh, for understanding Ohm's law, before going to the various terms used in electrical circuits, for understanding Ohm's law clearly, I will show a very nice animated video so that you could be able to get clearly what is Ohm's law. Okay, see this video. So here the statement it is telling, see here, the electric current flowing through a metallic wire is directly proportional to the potential difference across its ends, provided its temperature remains same. Okay, this is called the Ohm's law. So here, this video is very clearly explained that the Ohm's law. See the voltage, that is the potential difference across the wire, is directly proportional to the current which is flowing through the wire. And V by I is always constant. This is also clearly explained with an experiment. So hope everybody you understood clearly with this animated video. Okay, now we'll go back to the presentation. Okay, here. So we have seen the Ohm's law. Now we will see the definitions of various terms which are used in electrical circuits. Okay, circuit. We generally use this word. A circuit is a conducting path through which either an electric current flows or it intended to flow. That is called a circuit. And active elements. What are the active elements? The sources may be voltage or current source which supply energy to a circuit or network are known as active elements. Passive elements. What are the passive elements? That are called even circuit parameters. So these are the various elements like resistor, inductance, capacitance, which are taking the power. Okay, these elements are called as passive elements. Linear circuits. What are the linear circuits? Linear circuits. A linear circuit is one whose parameters are constant. That is, they do not change with voltage or current. So the parameters are constant. They are linearly varying. Those circuits are called linear circuits. What are the non-linear circuits? A circuit in which the parameter change with voltage or current is known as non-linear circuit. Unilateral circuit. What is a unilateral circuit? A circuit whose properties or characteristics change with the change of direction of its operating current is known as unilateral circuit. It means a circuit whose properties are characteristics are changing with the change in the direction of its operating current. If the operating current is changing, then the characteristics also changing. That is a unilateral circuit. And bilateral circuit. What is a bilateral circuit? The circuit whose properties or the characteristics are same in either direction. In the both the direction of the current, the characteristics are not changing. It is same. So it is called a bilateral circuit. So I can say this is as a unilateral circuit, as I can take a diode as an example, and for bilateral circuit I can take in both the directions it should be similar. Okay, active circuit. What is an active circuit? A closed circuit, electric circuit, in which active elements like voltage source or current source are found along with passive elements is known as active circuit. Okay, so we know already that active element and passive element. Active elements are the sources, voltage sources or current sources. I can take a battery as an active element. Okay, and the passive elements are resistor, capacitor and the inductors. These are passive elements. If the combination of both the active elements and passive elements in a circuit, then that circuit is called an active circuit. Means in a circuit there should be an active element. Passive circuit. So, what is a passive circuit? A closed electric circuit in which only passive elements are present. Then that is a passive circuit. Okay, junction or node. What is a junction or node? In a network or a circuit, a point at which two or more elements are connected and where division of current takes place is known as junction or node. Branch. What is a branch? A branch, it is a part of a network or a circuit connected between two junctions is called a branch. Now, loop or mesh. What is a loop? A loop is a closed path and may contain active or passive elements or both. Okay, a closed path is called as a loop. Fine. So till now we have seen the terms which are used in electric circuits. Okay, now we will see the definitions of the Kirchhoff laws. What the Kirchhoff laws stating. Okay, okay, the first law. The first law is a current law. Okay, it is the first law. It is also known as a current law or point law. It states that the meeting at an electric junction in a network is equal to 0. Okay, so the meeting of all currents at a junction is equal to 0. That is, see, at this point, say this is a junction point. At this point, Here the I1 is towards the junction, so it is plus I1, and these two currents are away the junction, that is minus I2 and minus I3, which is equals to 0. So the meeting of all currents at a junction is equal to 0. In an electric network, even in this way also you can state it. Okay, this is good. The sum of the currents flowing towards an electric junction is equal to the sum of the currents flowing away from the junction. Okay, that means I1 is equals to I2 plus I3. Okay, then we will see the second law. What is the second law? Second law is also called as a voltage law. Okay, here the second law states that the sum of all EMFs and resistive drops with their proper signs in a closed mesh or path is equal to 0. So here if we, this is a circuit having two resistors in a circuit, R1 and R2, carrying a current I1 in the R1 resistor and I2 in an R2 resistor, but I1 and I2 will be same. Okay, as it is series, but it is indicated as I1 in, because it is flowing through the R1, and I2 because it is flowing through the I2, R2. Now here the current is flowing from positive to negative, so the drops, voltage drops is minus I1 R1 minus I2 R2 plus V is equals to 0. Okay, so here uh, you can remember by a hint. Okay, the direction of the loop and the direction of the current is same, then you put negative sign for a voltage drop. Okay, and as your loop is starting from positive to negative and the current is flowing from positive to negative, your loop is starting from positive of the voltage, hence you put positive V. Okay, this is only for the remembrance, there is no logic in this, this is only for the remembrance. Okay, so minus I1 R1 minus I2 R2 plus V is equals to 0. So this is about the Kirchhoff voltage law, that is second law. So in this session what we have discussed, we discussed about the definition of the current, the definition of the voltage, and Ohm's law, and the limitations of Ohm's law, and the definition of various terms which are involved in the circuit, and we discussed about the Kirchhoff laws and Kirchhoff voltage law, and we have seen one animated video also on Ohm's law. So hope after completion of this session, I think you have got some idea on Ohm's law and Kirchhoff current law and Kirchhoff voltage law. So thank you. We will meet in the next session.